Okay, Mrs. Howard's chemistry class. We're on Unit 12, Acids, Bases, and Salts. And you have several things that the state of Texas says you're going to be responsible for. And we're going to look at the first three in this section. We have C7b, you need to write the chemical formulas of common acids and bases. C10e, you need to distinguish between the types of solutions, such as electrolytes and non-electrolytes. C10g, you need to define acids and bases and distinguish between Arrhenius and Bronsted-Lowry definitions, and predict the products in acid-base reactions that form water. The other three we'll get to as we go farther on in lessons. Okay, so at the top of your notes page, you have a blank spot for acids and a blank spot for bases. You need to probably pause this and go get a pretty red pen and a pretty blue pen so you can get the acids in red and the bases in blue, because you know, what color does the acid turn the litmus paper? What color does the base turn the litmus paper? You got to keep this flowing, people. All right. So both acids and bases are electrolytes. We'll talk about electrolytes in just a minute. Acids have a sour taste to them. Bases have a really bitter taste. Acids turn litmus paper red. Bases turn litmus paper blue. What is litmus paper? Litmus paper, and I don't know who came up with this. You know, one of you guys will have to go and do the research. You can Google that. Litmus is made from a lichen, and a lichen, if I remember my biology, a lichen is made of, it's a symbiotic relationship, mutualistic relationship between a fungus and a moss. And it makes this really weird-looking little plant called a lichen, really tiny little things. And I don't know who came up with it, but again, somebody figured out, hey, if you put that in an acid, it turns red. If you put that in a base, it turns blue. Okay, acids react with metals to form hydrogen gas. You know this. You've done this multiple times in the lab. You take a piece of metal and you put it into an acid, say hydrochloric acid, and it starts bubbling. And that gas that it gives off, the bubbles that come off, are a hydrogen gas. Bases, not so much fun. Bases don't react with the metals. They, you know, it just kind of sits there. Okay, acids have a clean feel. Think of lemon juice when you get it on your hands. It's got a really clean feel to it. Bases have a look really slick or slippery feel, kind of like when you get soap on your hands. Examples of acids: vinegar, milk, soda, apples, citrus fruits. Some things don't necessarily have that sour taste like the milk and the soda, because they've got other stuff in them that cover up that sourness to it. Dr. Pepper has a lot of sugar in it, which makes it very tasty, not sour. Now, on the other side, you have bases. Examples of bases. You have ammonia, a lot of cleaning agents. Lye is the old name for sodium hydroxide. Antacids, you know, when your stomach's feeling, they say it feels sour, or you have indigestion, you take an antacid like a Tums or the milk of magnesia or the Rolaids or something that makes, kind of neutralizes the acid, excess acid that's in your stomach. And then baking soda, of course. We've used lots of baking soda in class too. Acids have a pH less than 7, pH less than 7, pH less than 7. Bases have a pH greater than 7, much greater than 7. So pH less than 7, acids. pH greater than 7, bases. pH, tilt your head this way, less than 7, it's an acid. pH greater than 7, it's a base. Acids produce hydrogen ions when you put them in water. Okay, what that means is when you put the hydrochloric acid, the HCl, in water, it splits into ions, and one of those ions, for if it's an acid, will always be an H ion. You'll see this written in a couple of ways, or referred to in a couple of different ways. If it's the H ion, a lot of times they'll just write the H plus ion. Sometimes, though, they'll write it so that you see that the H ion hooked up with a water molecule. So instead of having H2O, you have H3O plus. It's an ion. So they also call it the hydronium ion. We'll talk about that a little bit more later too. If it's a base, it produces hydroxide ions in water. So you have hydroxide ions in the water. So again, hydroxide, OH negative, it's on the right-hand side of your ion chart. All right, properties again. We talked about electrolytes. Electrolytes means that a solution will conduct electricity. So we can hook the little conductivity tester into it. We can take the little prongs and put them in there, and it'll light up both lights or one light, but the electricity runs through it. If it's a strong acid or a strong base, it's going to be a strong electrolyte. If it's a weak acid or a weak base, it's a weak electrolyte. That's where the words strong and weak come in when we're talking about acids and bases. Okay, oh look, acids have a pH less than 7. 0 is up at the top. And you see some examples of things that are just common things. Lemon juice has a pH of 2. Wine has a pH of 4. Rain has a pH of 5.5. Acids affect indicators. There are lots of different kinds of indicators. We've used 2 major indicators in class. We've used a little bit of litmus paper, but more so we've used the universal indicator, which is really a combination of several indicators. And indicators are chemicals that change color at a certain pH. So they put several of them together so that it'll be one color when it's a pH of 2, and a different color when it's a pH of 3, and another color when it's a pH of 4, and so on. Blue litmus paper turns red when it's in an acid. So litmus paper turns red with an acid. Acids react with metals. We have a lovely example. And we have HCl plus magnesium. We took a little strip of magnesium metal, then a little strip of magnesium metal, and we dropped it in a test tube with hydrochloric acid, and we formed 2 things. Magnesium chloride, which you couldn't see because it was dissolved nicely in the water, making a lovely clear solution. But you also saw bubbles being given off, and that was the hydrogen gas. How can you tell if the gas that you produced is hydrogen? Do you vaguely recall we lit one of those little wooden splints? We set it on fire, and then you put it over the mouth of the test tube, and it made a big pop sound. It's like a little miniature explosion that was going on. Hydrogen gas is highly explosive. Acids also react with carbonates, and this wasn't one of the ones on your list, but this is an important one because carbonates are things that make up chalk, marble, and you have a lot of statues. Think of all the statues that are marble, and all of them are outside. And can you imagine what happens to those marble statues when you are in a Los Angeles or something where there's a lot of acid rain? Here we have the equation. We have 2HC, if I can read it, 2HC2H3O2, that's vinegar, plus Na2CO3, that's baking soda, and you produce NaC2H3O2 and water and carbon dioxide. All right, so when you were in grade school, you made those volcanoes where you put some food coloring in the vinegar and you poured it on the baking soda, and you had lots of foam and bubbles and everything. So you've got the same stuff going on. We've done this in our lab before, and if you're not really careful about cleaning up the lab afterwards, that NaC2H3O2, that sodium acetate, is interesting. It forms these really white crystals that kind of spread all over the place, and it's kind of cool actually to look at, but they just, everywhere they touch and where the solution falls over, it just spreads all over the place. You get these interesting white crystals all over the place. Okay, here is an example of that acid rain, so putting acid on marble. Yeah, I mean marble. Just think marble. And you put the acid on it, and you're going to have a reaction. So this is an older picture of the statue, a statue of George Washington. And then I think it's about 70 years later, and you see the effect of the acid rain on the marble itself. It's actually breaking up the marble that you see there. You know, someone didn't go back and smack it upside and, throw things at it and make it crack. That's the acid that's been slowly eating away. Now, is marble tough? Yes, absolutely. A lot tougher than the chalk that we'll use in lab. Okay, here we have bases. Bases have a pH greater than 7, and if you look, the 14 is down on the bottom, and there are some examples. You've got human blood, pH of 7.5, just slightly above neutral. Baking soda, 8.5. Detergent, like you wash your clothes in, 10. And bleach would be a 12.5. If you've ever had bleach on your fingers, you know it feels kind of slick or slimy. So bases also have an effect on the indicators. They turn the indicators, specifically the litmus, blue. So litmus paper turns blue when you put it with base. Oh, and there's another one here, and we'll use this in lab too. And this is some cool stuff too. This is phenolphthalein, and it looks totally clear when it's in an acid, like it just looks like water. But the second you put a little bit of a base in it, it turns this really nice, pretty, bright, pinky purple color. Little girls everywhere would love it. All right, so again, we hit all of the basic characteristics of acids and bases. They're electrolytes. Acids sour, bases bitter. Acids turn litmus paper red, bases turn it blue. Acids react with metals to form hydrogen gas, bases don't. Acids have a nice clean feel to them, and bases have a slippery or slick feel. Examples of acids: vinegar, milk, soda, apple, citrus fruit. Examples of bases: ammonia, lye, antacids, and baking soda. pH less than 7 acids, pH greater than 7 bases. And acids produce hydrogen ions in water, bases produce hydroxide ions in water.